having cleaner air for all of us to breathe. So that's the process that recently went through, and that's the rules that were established that Mr. Berry alluded to that were in effect in 2009 and that we will be complying with when the unit's constructed. This gives you a sense of the order of magnitude of the emissions. As you can look at it, one of the first considerations is, are we a major source or not a major source? And the level of permitting required is dependent on whether you trip that threshold or not. And the answer to the Title I type requirements is no, we're not a major source for any of those criteria pollutants or for the greenhouse gases. Well, if you don't mind, ma'am.
We can't even see those numbers. How do we know they're exactly what you're telling us? We can't even see those numbers up there.
Afterwards, I'd be more than glad to show them to you. I have a copy of the permit right here so we can look at those. These are the specific limits that apply to the incinerators. So these are concentration-based limits that would apply to each of the 9 pollutants that are regulated under those EC rules.
Could you name those pollutants?
Sure can. Particulate matter, or PM, nitrogen oxides, or NOx, SO2, or sulfur dioxide, HCl, cadmium, mercury.
HCl is?
Hydrochloric acid, hydrogen chloride. Cadmium is CD. Mercury is Hg. Lead is Pb. And dioxins and furans.
Is there some barium involved there, sir?
These are the limits that are under the EC
under
rules.
the chemicals, can you tell us what else other chemicals are involved there?
If you don't mind, I'd like to get through the presentation. We will have a question and answer, and if you have questions about other chemicals, we can certainly talk about those.
So if I can get that out, that'd be nice.
Okay.
Please, thank you.
So in order to comply with those stringent standards, this is the system that has been put in place. The incinerator, a dry sorbent injection system that also includes catalyst impregnated filters. What that means is that there's going to be a dry material that's going to be injected into the gas stream to be able to react with the gas stream as it flows through, and then it will be captured on the outside of those bags so that we can reduce some of the acid gases that would be associated with the gas stream. And then we also identified 2 supplemental systems that we put as contingency type systems. They are not required, but they can be employed if we determine that we want an extra level of protection to make sure that we're below the standards. There were 2 systems that we identified in the application. That's SNCR, or selective non-catalytic reduction, and a powdered activated carbon. Probably ask, why are you doing all that? And this just gives a little bit of a breakdown of the pollutants and how you would, and what they are used for, how they help you to reduce the different emissions that would be part of the gas stream. So the design of the system, the properties of the primary chamber and the secondary chamber, which we'll talk about, that is inherent and helps to control a number of these pollutants. And you'll see that throughout, where anytime you see design, that's specifically the incinerator or the add-on control device. For anything that's particulate matter or metal-based, right, those are basically something solid, if you think about it. So the cadmium and the lead right there, in addition to particulate matter, are particles. So mass is mass when it comes to some of those. So if it comes in as a mass, it's got to be collected and it needs to be able to be controlled. So we're going to use those fabric filter type systems to be able to control that. NOx is a product of combustion. So NOx is controlled through the good combustion, and if we determine that we need that add-on, that's where the SNCR would provide additional control. SO2 is where that sorbent injection comes into play. That's the acid gas type control. Also, when you collect that material into the sorbent, it's collected on the outside of the bags and therefore controlled and drops into the fly ash. HCl, once again, through the dry sorbent injection. Mercury is both a gas and a solid, so you have to look at it from both forms. So there's a number of different ways that you can control mercury. The first one is waste segregation. If mercury doesn't get in the waste, it can't come out as an emission. So that's one of the main things that the new rule specifies. It's going to be one of the main things that IWMS is going to be working with the customers to make sure that mercury does not make it into the waste. And Florida actually regulates it so that mercury is not allowed to be in waste that would go to an incinerator. So it really comes back with educating and utilizing the generators, the waste generators. Doxyfuran, once again, comes down to some waste segregation, and really also what they call the 3 T's of time, temperature, and turbulence. It really gets down to how you control that combustion process to try to reduce the ability for doxyfurans to form. So, it sounds real good, you have low emission limits, but how do we know? How do I know and how do you know that we're complying with those emission limits? And there's a number of things that are put in place to be able to ensure that. The first is that as soon as the unit is constructed, there's an initial performance test. So all the pollutants that we just talked about, there will be a stack test company that will come in, the facility will be required to operate, and they'll be required to test and sample and demonstrate compliance with those emission standards. While that test is going on, there are also these operating parameters that you see at the bottom of the page here. Different operating parameters that are required to be monitored. And what you do is you establish a correlation between, or a relationship between a parameter and the emission level, and then you continuously track those different parameters. So a good example would be the temperature. So you have temperature controls. You have minimum flow rate type of control. So different things so you can control the operation of the unit to ensure that you're meeting those standards. And those are maintained, kept, reported on a continuous basis. This gives you just a flavor of the relationship and how it fits together. So you have the primary and secondary chambers, which is where the combustion process occurs. The gas itself with heat then goes through and it's recovered, as General Berry talked about. So therefore that's where we can generate the electricity in the heat recovery boiler. The quench system is where water is introduced into the system so that we can lower the temperature to be able to protect that fabric filter. The last thing you want is for really hot gas to be going through that fabric filter and potentially have an issue there. So we're going to drop that down through the quench system. Right before that, we have that injection of those controls of the acid gas. And the bottom 2 units that you see down there, the emergency generators. One of the main concerns here is that we know that there are thunderstorms, we know that there are power outages, we want to make sure that there's not going to be bypass events or emissions that would be associated with those. By having the emergency generator, if we lose power, that unit is able to operate the incinerator and the air pollution control device. So we do not lose the process if we lose power because we have the backup. One of the other distinctions, and I know some folks were talking about it, is what happens to this material? The material comes in as waste. What actually happens to it? What's the breakdown? How do we see where it all goes? And if we use just one pound, or the number 1 kind of as a unity, if 1 pound of waste comes in, there is between 1% and 5% of that would end up as ash. So ash would be the inert material, the metals, anything that cannot be burned. So that would come out in the fly ash, in the bottom ash that you would see right at the bottom of the primary chamber. So that's 1 to 5% of that. The remaining material is therefore then combusted and goes through and is turned into a gaseous phase in the primary chamber. In the secondary chamber is where it is further reduced. And from that point on, that goes through the air pollution control train, such that at the end of the day of what comes out the stack, 99.9% of that is nitrogen, O2, CO2, and water vapor. The 0.1% of that is what is regulated in those other pollutants that we talked about and that are in the EC rules.
What rules are the EC rules, if I may ask?
Yeah, I think we're ready for questions.
Let me take your questions. I'll start
Over here.
on this side, and then I'll take one on this side, ma'am.
I want to know, where does the water go?
Okay.
How do you filter it? Keep it
Could you
out
hear a
groundwater.
question? No. Where does the water go?
That you use to cool the gases.
That
I don't want it in my drinking supply.
I
I'll get right
understand.
next to it.
Great question. The question was, where does the water go that you use to cool the gases? The thing about it is because of the temperature of the gas as it comes in play, it gets vaporized. So the water, there's no discharge water that goes with that. It actually gets vaporized and is part of the exhaust stream that gets exhausted.
I'd like to point out that tonight is not a hearing, and you're not sworn to tell the truth. What guarantees does the public have that we're hearing the whole story tonight? Is there any
I'd like
guarantee?
to answer that.
Okay.
Ms. Long, we are very sincere about getting the truth out. We are. For one thing, I have to tell you, I listened to your radio interview that talked about that this might be a dump. And I'm saying that, okay, I'll go here.
Take your stuff out of Jacksonville.
I'm saying